What up? It's your boy C Brizzy coming at you with Chapter 10, Lesson 2, Measuring Angles and Arcs. Our objective for this video is to identify central angles, major arcs, minor arcs, and semicircles, as well as finding their measures, and most importantly, finding what is arc length. So what is a central angle? The central angle of a circle is an angle with a vertex at the center of the circle, and its two sides are two radii of the circle. So in this picture, angle 1, angle 2, and angle 3 are all central angles. They all have a vertex at the center of the circle, and their two sides are radii. So there's angle 1, there's angle 2, or angle 3, here's angle 2. And the measure of the central angles of a circle have to add up to 360 degrees. That just makes sense. Okay, so here's an example. Let's solve for, in our guided practice, let's solve for x. So we know that 165 plus 145 plus x has to add up to 360. So we can just write it out. 165 degrees plus 145 degrees plus x degrees equals 360 degrees. 165 plus 145 is 310. So x is 50 degrees. Over here we have a 90-degree angle box. So 40 plus 85 plus 90 is 215. From 360 is 145. So x is 145 degrees. An arc is a portion of a circle defined by two endpoints. A central angle separates the circle into two arcs with measures related to the measures of a central angle. So we have one central angle here, two central angles here. And you'll notice something, what we're going to get into, is that this central angle here is less than 180 degrees, while this central angle is greater than 180 degrees, which leads us into different types of arcs. So we have a minor arc, which is the shortest arc in a circle. It is less than 180 degrees. A major arc is an arc that is greater than 180 degrees, and a semicircle, which is exactly 180 degrees. Now, notice, while naming arcs, an arc that's less than 180, a minor arc, is only notated with two letters. Okay, so that arc is notated with only two letters. A major arc and a semicircle are notated by three letters. And you notice that they go in order. They don't just skip around. So you can't call this arc here BAD. It either has to be ADB, or if you went in the reverse, you could have called it BDA or BDA. Would have been okay. Okay, same thing with the semicircle. So if it's automatically got two letters, it's a minor arc. If it's three letters, it's either a major arc or it's a semicircle. Okay, so here's just an example. So PM is a diameter of circle R. Identify as major arc, minor arc, or semicircle. So MQ has only two letters, so we know right off the bat that arc MQ has to be a minor arc. M and P, so if I go draw from M to N to P, and blue is probably a bad color for that, so let's just go back to red. M to N to P, and if you really want to do something else, you can draw and follow the line that's going across. MP was our diameter, so any arc created by a diameter also creates a semicircle. Okay, arcs of diameters. And then N, M, and Q going around, and we'll do this one in, let's do a dark green. Well, no, I don't want to do green. I already did green before. Let's do an orange. M to N all the way around to Q. That is a major arc. Congruent and adjacent arcs. Congruent arcs are in the same or congruent circles that have the same measure. Okay, so just any arc that has the same measure can be congruent arcs. And adjacent arcs are arcs in the circle that have exactly one point in common. So they share an endpoint. So in circle M, I have to draw this in, arc HJ, and we use this symbol for arc. We literally just draw a little arc. And JK are adjacent arcs. And the reason they're adjacent arcs is because they have one common arc point, and that's J. So just like segment addition postulate, just like angle addition postulate, you have something called arc addition postulate where you can add two arcs together to solve for the arc length and distance. Now, this is a bad example because by this picture, xy plus yz, yes, it's xyz, but that would imply that that's a major arc, and in this picture it's not. So this should be the measure of arc xz. Okay, so it's just saying that if this was like 20 degrees and this was 30 degrees, then 20 plus 30 degrees is 50 degrees, would be the measure of arc xz. Arc length is the distance between endpoints along the arc in linear units. Since an arc is a portion of a circle, it is then a fraction of the circumference. So arc length is just saying, hey, let's just find a portion of the circumference. And it follows this formula. X divided by 360, where X is your central angle measure. So the other thing is you want to know is that this is your central angle measure as well, or the degree of your arc measure. Okay, is equal to 2 pi r. And what is this? But this is just circumference. Right? So essentially it's saying find the circumference and then multiply it by whatever fractional piece it is. And this central angle, right, is a piece of the entire circle that is 360. So here's an example of it in action. Given a central angle of 75 and a radius of 4, they did something that we're not going to do, and we're not going to approximate our answers. We're going to find our answers in terms of pi. So let's do that. So, round to the nearest hundredth? Yeah, I don't think so. Exact answers only. So, let's look at number 1. So our arc length, so we want to solve for AB. The measure of arc AB is equal to our x degrees over 360 times 2 times pi times radius. So we have, what is our x degrees right here? We have our radius. We plug in and solve. So we'll do 45 divided by 360 times 2 times, and I'm going to write the radius times pi because all we're going to do is plug this into our calculator. So 45 divided by 360, just times 6, because that's what 2 times 3 is 0.75, and I don't like that, and you know how I feel about decimals. So we could write 0.75 pi, or it's 3 pi over 4 centimeters. The next one, solve for AB. They gave us diameter. We want radius is 7. So the measure of AB here is going to be 80 divided by 360 times 2 times 7 times pi. Exact answers only. Go to our old calculator. 80 divided by 360 times 2 times 7. 3.11111. Don't like that. Change that to a fraction. I'm getting 28 pi over 9. Or you could write it as 28 over 9 pi, whichever one you're more comfortable with. This is the one you should get used to when leaving your answers in terms of pi. And the very last one, find AB. They didn't even make this hard on us. The measure of AB is equal to 120 divided by 360 times 2 times 8 times pi. Put that in your calculator. 120 divided by 360 times 2 times 8. 5.333. Nope. Give me a fraction. You get 16 pi over 3, and this is feet because don't forget, this is technically circumference, so I should put that in meters as well. All right, that's all for me.